Pooh, Piglet, Christopher Robin, Owl, Rabbit, and everybody, all of Rabbit's kin, even a little rabbit who's just barely named Beetle something or other, ends up sticking his head in the hole and not coming along, set off on an expedition to find the North Pole. Now there's two North Poles. There's the geographic North Pole, which is the point around which the Earth rotates. So if you're to take a look at the Earth and it's slowly spinning through space, and you stick a point where it doesn't move, because as the Earth rotates like this, like a record player, it would be the spindle of the record player, the exact middle of the record player. So if you're standing at the North Pole and looking straight up, all of the stars would make this big circle above your head, as opposed to a circle off to the side or anything like that. And that's the geographic North Pole. And so the lines of longitude and longitude were set up so that they all converge on the North Pole and all converge on the South Pole. So the North Pole is where all of the distance south is measured. So it's however far south. And there's an old joke. You have a room. All of the windows look south. What color is, there's a bear outside. What color is the bear? The bear is white because it's a polar bear, because the only way you can have a room with all of the walls looking south is at the North Pole. There's another riddle. You walk 10 miles south, 10 miles east, 10 miles north, and you end up in the same place. Where are you? And the answer is the North Pole. Because 10 miles south from the North Pole, you're 10 miles south from the North Pole at some point. Doesn't matter where in the circle. Then you go 10 miles east, and then you're partway around the Earth, about a third, and then 10 miles north, and you're back at the North Pole, because you're on a circle 10 miles south from the North Pole. So if you go 10 miles north, you're at the North Pole. Now, the second North Pole is the magnetic North Pole. And the magnetic North Pole is where the compasses all point. Now, the Earth spins, and inside the Earth there's a liquid metal core. And the liquid metal core spins a little bit, and this generates a magnetic field. The problem is the core isn't exactly aligned with the outside of the Earth. So the core spins on an angle a little bit, and the Earth spins at a slightly different angle. And so what happens is the magnetic North Pole is pointing elsewhere. It's actually pointing to Canada. So if you have a compass and it points north, you're actually going to someplace in Canada. And if you go off a little bit, then you'll end up at the magnetic North Pole, which, as I said, is somewhere in Canada, which means that to go to the physical North Pole, at one point you're actually walking south from the magnetic North Pole. And you need something like a sextant to know which way to properly go and to track the North Star. Now, the North Star, Polaris, is coincidentally directly above the North Pole. And this is very useful for navigation in the Northern Hemisphere. There's no similar star in the Southern Hemisphere. But remember I said the magnetic core of the Earth is tilted a little bit to the outside of the planet. Well, the outside of the planet does a little wobbly thing. So right now it's Polaris. In 100,000 years, it'll be something else. 50,000 years ago or something like that, it was Vega. So there's all these stars that are just kind of close. And the planet wobbles and it goes to one and then the other and then eventually back in a circle. And it's a few 100,000 years to go in the full circle. Now, there isn't a physical pole at the North Pole. The North Pole is in the middle of the Arctic Ocean, and so that's mostly covered with ice. The thing is that it's mostly covered with ice, and because it's water mostly covered with ice, you can't really stick a pole in it because the pole would float away. And the North Pole is actually uncovered with ice part of the year. Sometimes it's open ocean. And one of the things that the U.S. Navy does is they take their nuclear-powered submarines. They can stay underwater for months. They don't have to come up. Nuclear submarine can stay underwater until they run out of food. I mean, that's the limitation of how long the sub can stay underwater. So anyway, they can go up to the North Pole. They can go wherever they want. And so one of the things that they do is they pop up at the North Pole. And Paul, my son, has a cousin who was in the Navy and was on a submarine. And what they did one Thanksgiving was they popped up at the North Pole and they played football on the ice. So here you have a bunch of sailors getting out of the submarine, running around on the ice, throwing a football back and forth for Thanksgiving. So that's one of the kind of cool things. And there is no physical North Pole. There is a physical South Pole, though. So the South Pole is in the middle of Antarctica, which is in the middle of Antarctica. Antarctica is a continent, and it's covered with ice. And the U.S. has a research station called the Amundsmen Ice Station right at the South Pole. And it was built there. And they have a pole that they stuck in the ice right where the South Pole is. And because the ice is kind of drifty a little bit, and the planet's a little wobbly, and things like that, they have to move it ever so often. But they put a physical South Pole there at the South Pole. And the Amundsmen Ice Station, named after two explorers, Amundsmen and Scott, who ran two separate expeditions to try and be the first one to go to the South Pole. Scott was an Englishman, and he had mechanical snowmobiles and all sorts of things like that. Amundsmen was running an American expedition, though he was Norwegian. And he ran dog sleds. And so he took all sorts of Eskimo tricks, and he managed to make it to the South Pole first. And then Scott made it. And then Amundsmen made it home. And then Scott just couldn't quite make it. He ran out of food, he ran out of supplies, he ran out of time. And lots of people have died going to the South Pole because it is desolate. It is essentially a desert, if you can believe it. The Amundsmen Ice Station is sitting on 9,000 feet. So that's almost 2 miles of ice. They're sitting on almost 2 miles of ice, but it never precipitation. There's no precipitation there. There's like no snow. There's no rain. There's no anything. So it's essentially dry. You have to melt any ice. You have no food because there's nothing to live on there. Yes, there's penguins at the South Pole, but they all live around the edge. And once you get any distance inland, there is nothing but ice and crevices and death. But they built this station at the South Pole, and they fly in supplies, and they fly in whatever they need. They fly out people, they fly in people. So that's a really kind of cool thing. Now, as I said, magnets, there's the magnetic North Pole and the physical North Pole. The magnetic North Pole has been moving, and it has been moving a lot recently. It's been moving more now than since they've been keeping records on this. And there's a theory that it's going to reverse itself because it's moving, and they have history of it reversing itself. Now, as I said, it's moved more than they've ever tracked, but how did they know it moved, flipped positions? Well, the Atlantic Ocean is spreading apart. And this is something that you can measure with like a yardstick and a calendar. It spreads a few inches every year. So if you stick two poles in the ground, one on either side, Iceland is the only place where this happens because the rest of it's underwater. You stick two poles in the ground and then come back 6 months, a year later, they're an inch further apart. A couple years later, they're a foot further apart. And so the ground is spreading apart there. And they've taken a look at the way the magnets were aligned, because as the rock cools and if it has iron in it, the iron will align with the way the planet's magnetic field is. So the iron aligns with the planet's magnetic field because magnetism just kind of picks itself up and things organize in that way. But they found rocks that were pointing north one section, and then a couple 100,000 years of spread further over, they were pointing south. And then a couple 100,000 years of spread further over still, they were pointed back north. So they figure every few 100,000 years, the Earth magnet flips. And it's kind of overdue, and it's kind of been moving quickly. So maybe in your lifetime, maybe in your kids' or grandkids' lifetime, the Earth's magnetic pole will completely flip. And there will be discussions about, well, do we keep calling north north? And the whole thing is rather arbitrary. I mean, words are arbitrary, and calling north north is arbitrary. But uh, anyway, magnetism. Uh, magnetism. Yeah.